piecewise function is a function defined by two or more functions over a certain domain. If I said f of x equal x squared plus 1 when x less than 0 and x minus 1 when x greater than 0. If I need to find the value of f of 2, let's see 2 is greater than 0 or less than 0. 2 of course is greater than or equal 0, so I'm going to substitute or replace x with 2 in x minus 1 equal it will be 2 minus 1 equal 1. If we need to find f of negative 2 less than 0 or greater than 0, negative 2 less than 0 of course, so I'm going to substitute in x squared plus 1. That means f of negative 2 equal negative 2 power 2 plus 1, that means equal 5. Here we have how to graph the piecewise function. I need to graph f of x equal x squared plus 1 when x less than 0 and x minus 1 when x greater than or equal 0. First, determine the shape of each function. Here I have x squared is a parabola curve or U shape, and x minus 1, this is a linear function or straight line. Let's determine the boundaries of the of each function, the boundaries of each function. Here I have first one, x squared plus 1 when x less than 0. First, determine the vertex in x squared plus 1. We are going to sketch x squared plus 1. So the vertex equals 0, 1. No horizontal transformation, but 1 unit up. So I'm going to draw at 0, 1 the parabola, the first one. But I need this function in the interval x less than 0. So I have to cancel or remove the part from this parabola in x greater than 0, like this. Then draw the straight line x minus 1. You can draw it using tables, or you can transform the straight line which is equal x, like this. I need this to draw this line x minus 1 in the interval x greater than or equal 0. That means I don't need that the numbers which is less than 0. So I'm going to cut or remove the part in x less than 0. And you have to take care of the 0 point. Here I have in the first one 0, it's not equal 0, so the point is open. But in the second one, the point x greater than or equal 0, so the point is closed. Another example, here I have 3x plus 2 when x less than negative 2, negative x when x between negative 2 and 1, finally x squared minus 2 when x greater than 1. I have here two linear functions and one power 2 or square function, that means parabola type. Let's graph the first one. Here I have the first one is 3x plus 2. I can draw the straight line using tables, or I can sketch this line by transformation. Okay, let's see. If I said using tables, that I'm going to replace x. I have here x less than negative 2, so I'm going to start with negative 2, and then it's less than negative 2 means negative 3, negative 4, and so on. So this is the first line. The straight line, the first straight line here is 3x plus 2, but I need it in the interval x less than negative 2. X less than negative 2, that means I'm going to remove all the parts after negative 2, like this. Then negative x when x between negative 2 and 1. I'm going to draw the straight line negative x like this using tables, okay, and numbers between negative 2 and 1. Then I'm going to remove any part outside the interval or outside the interval negative 2 and 1, like this. And negative 2, of course, it's a closed point, and 1 is an open point. Finally, draw the parabola x squared minus 2, that means the vertex equal 0, comma, negative 2, right? So I'm going to draw the parabola, and then I need only the interval x greater than or equal 1. So I'm going to remove or cancel the part less than 1, like this. Finally, this is the graph of the three functions in piecewise function. Another example, here I have x plus 4 when x less than negative 4, to x plus 5 when x between negative 4 and 1, negative x plus 3 when x greater than 1. The three lines are, or the three functions are linear functions, so I'm going to draw each line in its interval like this. First, start when x less than negative 4, start to draw the first line, which is x plus 4. I can use table, and of course I'm going to pick values for x less than negative 4. Start with negative 4, then negative 5, negative 6, and so on. Right. Then between negative 4 and 1, I'm going to draw the second line, and both 2 points, negative 4 and 1, are closed like this. Then go to negative x plus 3 when x is greater than 1. That means I'm going to choose numbers start from 1 and 1, of course it's an open point, then 2, 3, and so on, like this. Okay, here I need to find the domain of this function and the range of this function. First, the domain here is given x less than negative 4 and from negative 4 to 1, then finally it's x greater than 1. Right, so the domain of these three functions, or the piecewise function, is start x less than negative 4 means negative infinity. Finally, it's end with x greater than 1, so it's infinity, positive infinity, so it's from negative infinity to infinity, or r. And of course I'm going to take care of the boundary points, which is negative 4 closed and 1 closed. Then find the range. The range start, here I have the lowest point on the function is negative infinity, because it's an arrow, right? And it's end with a certain point, which is 7, so it's from negative infinity to 7.